Hey guys, good morning. I'm back again just to reiterate a few things and to show further confirmation on my hypothesis. Okay, first off though, let's start with the Ramby slider, coloradostate.edu. Link will be in the description box on the top. Full disk, natural color. Put it on the most images, least number of time. We still have that object. So this is a GOES East 16 satellite. It's parked somewhere in this geosynchronous orbit on either side of the planet. The Himawari one that I've been showing you in the evenings is parked and giving you weather data from the western side of the planet, which is Japan and Australia and all that region. And the GOES 16 gives you South America, North America, and some of in most of the Atlantic, some of the Pacific. Well, anyway, whatever. But so here we go. Discovered this back on the 17th. When it showed up on the 17th, it was much closer because they were having to pixelate out this area, this entire area down here, in order to cover up whatever this object is. So since then, it's been what, 11 days? This is 28th. It's clearly on the move, and I would submit that well, it's moving away from the satellite, and I don't know. I would think it's heading toward the planet. Could, maybe not. It could be just sliding past. We'll have to wait and see, I suppose. I'm surprised nobody's come up with any images in Australia yet, although I have seen some images in the past. So I don't know. Who knows? All I know is this ain't right. And there's a lot of stuff up there. All right, here's the ACE tracking data plots, which I came across yesterday and I showed it to you. We got a 48-hour plot and a 6-hour plot. Yesterday I showed you these gaps here on the late on the 26th, corresponding to gaps on the ACE. So the gaps are due to objects in between ACE and the ground tracking stations, which are here on Earth. And here's a list. And then there's an unknown one. So that's kind of weird, but everything's weird nowadays. So just to reiterate, there's the ACE. This is the ACE last 3 days. Here's the two little gaps I showed you yesterday. And then we have one little gap showing up late on the 27th. That would be here. And there it shows you there. But other than that, it's a clean run. In the last 6 hours, they're clean. So just to illustrate what I've been showing you, if you haven't been watching these videos, this is a video I put up back on September 29th. That's when I recorded the solar wind speed at 1,372 kilometers per second. They're on ISWA. I mean, it's been an ongoing process, guys. I get revelations or epiphanies, sometimes even when I'm just narrating a video. I think that's what happened here. Well, no, I guess it happened the video before, or on 9/27, I had some type of an epiphany. I can't even remember now. There's been so much. But here's the big gap I've been telling you about. And this gap was ever since I started making vids and pulling up these ACE satellites, which was somewhere around the beginning of the year. My channel came back online on the 13th, I believe, January, or the 18th, 19th, somewhere around there. and I started making vids, and shortly thereafter I started pulling up some of this space weather stuff and the ACE gaps. So originally the gaps started around, and I can't put the cursor up any higher or it'll, okay. Normally the gaps started around 2300 and they went to maybe 0400. Then they kept getting bigger and bigger until finally, this is September 29th, and they lasted all the way up until October 14th. This gap level, like 9 hours. So that's when the big planet started to get close. And you can see on here, see how the solar wind speed's getting splashed all around? Now I hadn't realized it back then, but I think it's due to the magnetosphere from this big planet splashing things up, messing things up. So I mean, just picture a big magnet. Earth's a big magnet, the sun's a huge magnet, this planet's a big magnet, has a magnetosphere, so its magnetic field is splashing up the solar wind coming from the sun, and that's why the ACE recording looks so funky. Here's the sun. This is the L1 Lagrange point. This is where ACE and Discover both reside, 930,000 miles in front of the Earth. Of course, the sun's way out here. This isn't the scale. So the big planet was coming toward ACE for as long as I've been making videos. The gap on ACE was 4 to 5 hours. There was no gap on Discover. So obviously ACE and Discover, even though they're at the L1 Lagrange point, they're pretty far apart, if you get what I'm saying. Or the gap would have showed up on Discover too. Then finally it got to be the 14th, 15th of October. The gap was at its max, like about 9 hours. And then on the 16th and 17th, we had no gap. So it passed the ACE satellite. Then their gaps started showing up on Discover. Now here's the Discover tracking station. I showed this to you yesterday too. We had the big 12-hour gap on the 25th. We had a small gap here on the 26th, and a small gap on the 27th. But since then, it's been clear sailing. So I would submit to you that whatever these objects were, and I would say one's a big planet, to be sure, with a magnetosphere, or else it wouldn't be splashing up all that solar wind data coming to ACE like it is, and also causing fluctuations in the solar wind speed and density once it gets to Earth. I think when it's creating maybe some eddies around the Earth. And remember, this is like a dead zone in between. These are being measured by the GOES 13 and 14, as far as I can tell. This is the ISWA, the simulations I pull up space weather. These are at 22,236 miles above the planet. ACE, this is the sun side. Way out here, ACE and Discover, 930,000 miles. So this whole gap in between, there's no satellites or anything out there recording. Well, there might be, but if they are, they aren't sharing it with us, or I haven't found it, that are recording the space weather. So my contention is this big planet was flashing up the data coming to ACE. That's why you get all these fluctuations still showing up. And now that it's past ACE, and it was happening even before when it was in front of ACE and Discover, you would get these solar wind numbers that were extremely low. And look at these solar wind speed numbers, 325. Average is between 400 and 700 kilometers per second. So you can see it got up around low end of average. Now it's on the way back down again. But if you watch the magnetopause, it's getting rocked by some kind of solar wind. So I'm saying this planet has to be creating either eddies and disturbing the solar wind and like blocking it to some degree. And of course, with Nemesis behind here, it's presenting its own solar wind out here, so it's creating blockages up here. So every once in a while, these density blockages and solar winds come through, and that's what's rocking the magnetospause, in my humble opinion, along with the magnetosphere being weakened, obviously, because look at all this plasma having to be ejected all the time. And every time these field lines close, that's taking energy from the Earth in order to ward off all this backside pressure. These three are synced up. A couple times in here we came up to above 1,000 kilometers per second on the solar wind speed. It's not worth dragging everything through. I'm just going to let them play through. These three are synced together, and these two are synced together. This is giving you all the low energy electrons coming from Nemesis, and these measuring all the highest high energy electrons coming from Nemesis. Now if you notice behind here, see this line? That's a false bow shock. See, it extends way up here, but this is all whited out. So this energy in here is even beyond its blacks and purples. It's beyond what this simulation can read. So it's just showing it as a whited out area. I showed it to you on a couple videos back on, I think the 25th was the big splash that was all blacked out on from the energy, high energy electrons. It was all had the MLSO all blacked out. Something on the 26th too. That yesterday and today so far they have those X'd out. That's the Mauna Solar Observatory, K-core, by the way. So obviously this thing's still closer to ACE, I would say, but it did interrupt the data feed from Discover getting to the Earth. And this is one thing that puzzles me. See these solar wind densities? If this scale is correct, these things are all down below 1 on ACE. But on Discover, all that went down around 2, 3, and the average is 4 to 6 atoms per cubic centimeter. So these things don't exactly jibe. In the description box, pull up their solar ham space weather tutorial. This is the phi angle. Anything 180 on the 180 line would indicate a direct connect with the interplanetary magnetic field connection from the sun to the Earth. 0 is from the Earth to the sun. Now this thing, they bumped it up 40 to 400 because we're getting so many backside connections. I guess they want to measure them. We're getting so few Earth to sun connections. So anything above 180 indicates a direct connect to something behind the Earth, the solar body. And as you can see, most of the time Earth's being connected to Nemesis, which would reflect on all this stuff coming from behind, all this high pressure. And so all this data here is being measured by satellites in the geosynchronous Earth orbit. It goes 13 and 14, I believe, along with the solar wind speed. So when you see it, see how much it's fluctuating? It went to 9, then it went to over 1,000. And you should really click that box down here, make this thing full screen, and you can really see what I'm talking about. I don't know if you peeked Earthquake 3D lately, but this is the last day on the planet. Earthquakes 2.5 and above on the United States territories and 4.5 and above from USGS feed. Generally speaking, show up on here. All these ones that are high off the globe, those are the deepest earthquakes. Now I had to pay 20 bucks extra to get the Earthquake 3D Plus, but it's a free download Earthquake 3D. Just Google it. Running out of time. God bless. Peace. And for now, I'm out.